All right, so we're going to talk about reciprocal functions, and we kind of mentioned these last week, so we're just going to briefly talk about them again, and then I'll show you how it works. So our main trig functions that we've learned in the past are sine, cosine, and tangent, which hopefully you remember are opposite over hypotenuse, adjacent over hypotenuse, and tangent is opposite over adjacent. So that's a review. We've been working with that for a while. We talked last week about three other functions: cosecant, secant, and cotangent. And so I'll write it the way we write it in like simple form. We have cosecant. Whoa, what in the world am I doing? Cosecant theta, secant theta, and cotangent theta. All right. So in order to do those, they are the opposite, the reciprocal of the others. So hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. So that's what they are. And sorry, this is kind of ugly, but it's fine. Okay. Um, and because they are reciprocals or the opposite of each other, we flip them over, you can actually write these as reciprocals. So I'm going to write that down here just so you can see it. It's also on the back of your notebook and should be something that you memorize as far as how to manipulate things a little bit later. So sine can be written as 1 over cosecant. Cosine can be written as 1 over secant. Tangent, 1 over cotangent. And you see that pattern. So I'm going to do that for the other ones. Cosecant is 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent. So these are just two different ways to look at the same thing. Later in this class, we're going to be replacing, sine with I don't know, cosecant and tangent with other things. And so it's important to kind of look at it that way. That's the gist. So let's see how this actually works. So you'll see instructions that say things like find the exact value of trig function. So we're going to actually find sine, cosine, tangent, secant, cosecant, and cotangent for just the ratios for all of these. Now, exact values means we're not going to be using the decimals, so we're going to go about it that way. So sine is opposite over hypotenuse. Oop, there's the hypotenuse down here. So sine would be 4 over 4 root 5. Now, we can't leave a radical in the denominator, so we do need to rationalize. We're going to multiply by the square root of 5 over 5. So we have 4 root 5 over 4 times 5. 4 root 5 over, and I can cross out those 4's right there, but I'm going to do it this way just in case you end up in that situation. So the square root of 5 over 5 is sine. Cosine is adjacent and hypotenuse, 8 over 4 root 5. And we go through the same process to rationalize. All right, now I am going to simplify this one here this time, just so you can see kind of how to recognize that. And cosine is the square root of 5, 2 root 5 over 5. Tangent is opposite over adjacent, so 1/2. And that's kind of what we've done before. These are the exact values. But now we're going to find the exact values also of secant, cosecant, and cotangent. Cosecant is opposite over hypotenuse over opposite. So 4 root 5 over 4, which is just the square root of 5. Secant is hypotenuse over adjacent. So we can simplify 4/8, so the square root of 5 over 2. And cotangent is adjacent over opposite. So 8 over 4, which is 2. All right, so you can see these are reciprocal identities, and that is all you have to do when we want to find the exact value. Now, sometimes they're going to leave out some information. Oops, I didn't even say what theta is, so let me stick theta over here. All right, we have to know what the angle is in order to continue, so that's that. All right, so I'm going to kind of show you how to get this one started, and then I want you to pause the video and try to go through all of these functions on your own. We are missing a side, and so the first thing we're going to have to do is find that missing side. It is a right triangle, and we know 2 sides. We want to know the third side, and so we're going to use the Pythagorean theorem. I'm using parentheses there because we have to square the whole side, not just the square root of 3. So 36 plus so the hypotenuse is 12, the square root of 144. At this point, I want you to pause the video and do all of the trig functions. Find the exact value of all the trig functions. When you're done, come back and check your answer. At this point, you should just be checking your answers. So I forgot to say welcome back before I started working, but welcome back. And you should be checking your answers at this point. All right, so hopefully you got all of those answers right for sine, cosine, tangent, cosecant, secant, and cotangent. Make sure you rationalize the denominator when you need to. Also, when you look at this one, as soon as I saw the 6 and the 6 root 3 here, I knew that this had to be a 30-degree angle because of those special right triangles that we've talked about. Remember, it's 1, 2, square root 3. So when I saw 6 and 6 root 3, that means that it had to be across from the 30-degree angle. So this angle would be 30, and this is a special right triangle, which will be helpful when we do these sometimes. All right, how else might you see these problems? We want to know the exact values of all of the trig functions based on this fraction. Now, when you see something like that, you need to actually get some perspective about what that means. So if you remember that cosecant is hypotenuse over opposite, that will help you figure out that missing side. I recommend drawing a triangle. We are making one of the angles theta. It really doesn't matter which one in this problem. We're just going to kind of play with it. It won't make a difference in your answer. So cosecant is the inverse, or the reciprocal, of sine. So hypotenuse over opposite. So we know the hypotenuse is 37 and the opposite side is 12. In order to do any of the other trig functions here, we need to actually figure out that missing side. We know two sides, we're looking for a third side, so we need to use the Pythagorean theorem. All right, and so we're just going to find out what B is and not, we're going to find out what B is, except we need to make sure that we have an exact value. So we need to simplify the final radical if it's not a perfect square. And I don't think that's a perfect square. Oh, it is. So B is 35. All right, now we have all three sides, and so you can set up all those trig functions again. So pause the video and come back to check your answers. Welcome back. I'm going to do these quickly. All right, sine is opposite over hypotenuse, so 12 over 37. Cosine is adjacent over hypotenuse, 35 over 37. Tangent, opposite over adjacent. And obviously, if we could simplify those, we would. Cosecant is the reciprocal of sine. So you can either look at the picture and do hypotenuse over opposite, or you can look up here and flip it over. Secant is the reciprocal of cosine. So 37 over 35. And cotangent is the reciprocal of tangent, 35 over 12. All right, are you getting it? Hopefully you're feeling a little bit more comfortable with using reciprocal functions. Number 4, I just want to point out one thing, and then you're going to pause and go through the whole process by yourself before you pick it back up. This is only one number, but we know when we have a fraction or a whole number that it really is over 1, right? And so remember, secant is the reciprocal of cosine. Yes, cosine. Whoa. And so that means this is hypotenuse over adjacent. So I want you to go ahead and draw a right triangle. I want you to label the sides, find the missing side, and then go through all 6 trig functions. All right, pause. Go. Welcome back. I'm just going to draw my triangle here, just in case you needed to see that. It's an ugly triangle. Secant is hypotenuse over adjacent, and we want to know that missing side. So I'm going to use the Pythagorean theorem. So 1 plus x squared equals 16. So x squared is 15, and x is the square root of 15. And so that's what we're going to be working with over here, because that is the simplest form. All right, let's go through. Hopefully you've already done this and you're just here checking your answers. Sine, cosine, tangent, cosecant, secant, cotangent. All right, so sine is the square root of 15 over 4, opposite over hypotenuse. Cosine is adjacent over hypotenuse, 1/4. Tangent is opposite over adjacent, 15 over 1, but I'm not writing the 1 because we don't need to. Cosecant is hypotenuse over opposite, and that's a case for rationalizing the denominator. So 4 root 15 over 15. That's not simplifiable, so that's the answer. Secant is hypotenuse over adjacent, which is what we were given to begin with, 4 over 1 or 4. And cotangent is adjacent over opposite. And again, we need to rationalize that denominator. All right, so those are the 6 trig functions. Let me circle these because they look like a mess. And hopefully they're the same answers you got. If not, let me know. All right, the last way you might see these is like this. Give the exact value of each function. So you don't need to go through all 6 here. You're just trying to find out the exact value of sine 60. If we type this in the calculator, making sure we're in degrees right now, if we type in sine 60 in the calculator, it's going to give us a decimal. That decimal is always the same for sine of 60. But this is not an exact value. It's an irrational number, and it does not, or it's rounded here. So what we need to find is the exact value, and the exact value looks more like this. So this is a special right triangle. When you see that 60, you should be like, oh, yes, that's a special right triangle. And you should be able to draw that guy. So when you see that at this point, you should be able to draw a right triangle and put your 60, and we want the sine of 60. Well, in a special right triangle, 30, 60, 90, the side across from the 60 is the square root of 3, right? Because across from the 30, it's 1, and the hypotenuse is 2. And all you have to do now to get the exact value is write the sine ratio. So the sine ratio of 60 is opposite over hypotenuse. And that's it. That's all you'd have to do to find the exact value. All right, let's do cotangent. So again, we know this is a special right triangle. We can draw our 45, 45, 90 right triangle. This is not drawn to scale. Put the 45 in one of the angles and think about what cotangent means. For me, it's easier to think about it as tangent, or like, write the 45 and I just write the little ratios here. 1, 1, root 2. After I write that, then I'm going to think about what cotangent means. Cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. So adjacent over opposite. So the exact value of cotangent 45 is 1. All right, so this is where it gets a little tricky, but you'll do great. Have a great day.